Optics is a branch of physics which deals with the study of nature, properties and effects of light. This optics is classified into two categories, that is the geometrical optics, or it can also be called as ray optics. The other one is wave optics or physical optics. It is a point on principal axis through which the light rays incident parallel to the principal axis passes after reflection from the mirror. Hello everyone, welcome to session 1 of chapter 9, Ray Optics and Optical Instruments. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in this chapter, we are going to understand the properties of light, optics, the branches of optics, that is ray optics, how the optics is classified into categories, and what are the phenomena behind the working of optical instruments, and many more important properties of light. So let us begin with the introduction, that is optics. So what is an optics? Why the name optics? So optics is a branch of physics which deals with the study of nature, properties and effects of light. So in simple words, it's a branch of physics that deals with the study of light and its properties. This optics is classified into two categories, that is the geometrical optics, or it can also be called as ray optics. The other one is wave optics or physical optics. So in this chapter we are going to understand about the ray optics, which means the geometrical optics. In the upcoming chapter we are going to understand the physical optics or wave optics. So what is a ray optics? It is a branch of optics that deals with the study of rectilinear propagation of light. What is the meaning of rectilinear propagation? It means light travels in a straight line, as we all know, and this phenomenon of the light which is traveling in a straight line is called as rectilinear propagation of light. So in this branch of optics called ray optics, we are going to study about the rectilinear properties of light rays. So to understand ray optics, first we have to know about some basic terms. So the first one is ray. What is a ray? It is nothing but a straight line along which the light travels. It is denoted by a straight line with an arrow mark. So one single straight line with arrow mark is called as a ray. Now, what is this group of rays called as? A bundle of rays is called as beam of light. We can observe a beam of light when the torch is switched on. So it's nothing but a bundle of rays. So the next important term to understand the ray optics is optical medium. What is the meaning of optical medium? Why do we call optical medium? It's nothing but a medium through which a light can travel. Any medium through which a light can travel, we'll call it as optical medium. So these are the basic terminologies we'll be oftenly using in the study of ray optics. So next let us move on to the properties of light, which includes the reflection of light. The first property we are going to understand of light, that is the reflection of light. What is the meaning of reflection of light? In simple words, in the lower standards, in the lower classes, we have studied that the bouncing of light, the bouncing back of the light rays when it is traveling in a medium is called as reflection of light. Yes, that is correct. And the process in which a light ray comes back after striking a surface is called as reflection. If a light ray is traveling in one direction, when it strikes a surface, the property of bouncing back, or the property in which the light ray comes back after striking, is called as reflection. So in this diagram we can observe this is how the ray is getting incident. So we'll call it as incident ray. After it strikes this surface, the light travels back in the same medium but in the opposite direction. So this ray is a reflected ray, and this is a normal to the surface. So the angle between the normal and the incident ray is called as angle of incidence, and the angle between the reflected ray and the normal is called as angle of reflection. Now based on the phenomena of reflection, we have two laws of reflection to understand. That is, the first law is, you can observe here, the angle of incidence. You got to know what is an angle of incidence now. So the angle of incidence, I'll call it as angle of I, is equal to angle of reflection. That is angle of R. So angle of incidence is equal to angle of reflection since it is divided with the help of a normal. So that's the first law. And the second law states the incident ray, the reflected ray and the normal to the surface at the point of incidence all lie in the same plane. They are all lying in the same plane. So these are the two laws of reflection which is very important to understand. Let's move on to another important topic called as spherical mirrors. So it's very important to understand the properties of mirrors and the lens in the study of ray optics. So we shall study about spherical mirrors now. So what is a spherical mirror? It's a reflecting surface which is a part of sphere and we call it as spherical mirror. So suppose if this is a spherical mirror, it's a reflecting surface and that is a part of the whole sphere. So we'll call it as spherical mirror. There are two types of spherical mirrors. One is a concave mirror, the other one is convex mirror. Now let us understand what are the parts of mirror. So understanding the parts of mirror is very important. Say for example, this is a mirror with reflecting surface. Now these are the incident radiations which are going and striking to this surface. So after striking this surface, they are reflecting back. And all these rays are coming and meeting at one single point which is called as principal focus. Principal focus is denoted by a letter F. That is one of the part of mirror. The center of this spherical surface, say for example this point, it is called as pole which is denoted by P. Now the line which is passing through this pole and through the center of the spherical mirror, we'll call it as principal axis. What is C? It is called as center of curvature, which means if we continue this forms a spherical form, or it takes a spherical form. It's a complete sphere and the center of this complete sphere, it is called as center of curvature which is denoted by C. Now the distance between this principal focus and the pole is called as focal length and it is denoted by small f. So what is the difference between center of curvature and pole? It is nothing but the radius of curvature which is denoted by capital R. So these are the important parts of mirror which we have to understand. This helps us in writing a ray diagrams. Let's glance one by one. Once again, the center of curvature of a mirror is the center of sphere of which the mirror is a part, which means the center of sphere, it is called as center of curvature. The next one we have pole. It is nothing but the geometrical center of the spherical surface of mirror. This is the geometrical center of the spherical surface of mirror. This is the spherical surface of mirrors. Geometrical center, we'll call it as pole. So next is radius of curvature. It is nothing but the distance between the center of curvature and the pole. And next we have principal axis. It is the straight line joining the pole of the mirror and center of curvature. You can see here the straight line which is joining the center of curvature and the pole, we'll call it as principal axis. Next is principal focus of concave mirror, or we'll call it as F. It is denoted by capital F. It is a point on principal axis through which the light rays incident parallel to the principal axis passes after reflection from the mirror, which means you can see this point. After reflection, the lines or the rays passes through this point. So it is called as principal focus. It is denoted by capital F. Next, principal focus of convex mirror. It's a point on principal axis from which the light rays incident parallel to the principal axis appears to meet, because they do not meet in real, they meet virtually. So they appears to meet after reflection from the mirror. So we'll call it as principal focus. This difference we can understand while writing the ray diagrams. So here we have a picture of convex mirror, where we can see here these are the incident radiations. After reflection they come back, but if they projected here, it appears to meet at this point. We'll call it as principal focus. This is exclusively for convex mirror. The previous condition what we have studied is for concave mirror. Now let us understand diagrammatically what is the reflection of light by spherical mirrors. First one, we have a concave mirror. You can see here, this is the center of curvature. We know these are the incident radiations which are going and striking a surface, and this is the center of the geometrical center of the spherical surface. We will call it as pole. After reflection they are all coming and meeting at this point, that is called as principal focus, and the distance between principal focus and pole is called as focal length. The distance between center of curvature and pole is called as radius of curvature. This is about concave mirror. What about convex mirror? So we have a convex mirror here. So these are the incident radiations which is passing parallelly to the principal axis, and after reflection they are coming back, they are emerging back to its same medium, but they appears to meet at this point which is called as principal focus. Again, the distance between principal focus and the pole is focal length. Distance between center of curvature and the pole is radius of curvature. So this is in case of convex mirror. So these are some of the basics and important terms related to the ray optics, which helps us to understand the ray diagrams in our further sessions. So let's all meet in the next session. Until then, keep learning all of you. Thank you.